Okay, in this session, I love this session because I'm going to teach you some shortcuts, some ways to make your life a lot easier. Now, you'll see on the screen right now, this looks like the session you just did that says, now you try. Here are all the answers that you and I got for all of the ions that are formed. Now, what I'm going to do is I'm going to show you a shortcut so you don't have to draw these every time. As a matter of fact, how are we going to do that? Well, we're going to use the periodic table. Now, in a previous session, I told you you needed a couple of copies of the periodic table. In one of the other sessions, we just labeled all the parts of the periodic table, filed this one away. I'm not going to use much anymore, but this one will be useful. Have to know some parts of your table. What we're going to do, we're going to take a different one. We're going to take one that you can write on, and we're not going to write on top of the elements this time. We're going to do something with it. I'm going to use some shortcuts that'll make your life a lot easier and makes the test a lot easier because you can actually see what's happening. Now, every time you have an atom or an ion, you can actually draw them out like we did and get the right answer, but we learned very quickly that there's some shortcuts that the periodic table does for us. What I want you to do is I want you to notice with me this one and this one. You'll notice they have the same charge. Why would they have the same charge? Well, remember we talked about valence electrons as electrons in the outside ring? One in the outside ring, one in the outside ring. Now, the only difference between this one and this one is that this one's bigger. It has 1, 2, 3, 4 rings in it, so it's a bigger atom than this one is, but it still just has one in the outside ring. Now, why is that important? All the rings inside that are already full, that's great, but it's these electrons in the outside ring that we're having to deal with so much. That's why they have a special name. So this guy and this guy both ended up with a +1 charge. If you look at your chart, lithium and potassium are in the same column. As a matter of fact, if you drew out hydrogen and sodium and vanadium and cesium and francium, which you don't want to draw these are huge, is they all look like lithium and sodium. As a matter of fact, on your chart, what I would do is I would write +1 on top of that column. Everybody in this column all the way down have a +1 charge. That makes your life a lot easier. Now let's see what else we can find. Let's look at beryllium. And if you look back at your notes, when we did magnesium, you'll see that he was also a +2. Both of them had 2 in the outside ring. So if you have 2 in the outside ring, you're going to always throw them away. Beryllium and magnesium are in the same column. That means they all act the same. Everybody in this column is a +2 charge. Always a +2 charge. Now when I say in the column, all the way to the bottom, all the way to the bottom. Now we're not going to go into these 2 rows because these guys are the inner transition metals. We're not talking about those. Now you don't have to draw that line. I'm doing it on mine so that you can see. So all the way down, all these guys, +2 charge. Let's look at this guy right here, aluminum. Well, aluminum is +3. So we went +1, +2, skip all the short columns. This guy and this right here, +3 charge. Now, why are they the only 2? Well, these short columns in the middle are called transition metals, and transition metals mess around with their electrons so much, they just don't follow the rules that everybody else does. So we're just going to talk about the columns that go all the way to the top. So the +1 goes all the way top, +2 goes all the way top, +3 is real tall. All of these are real tall. Any of these short ones in this bottom section, we're going to ignore them for now. They don't follow the normal rules. So those guys are +3. Let's jump way to the other side. Let's look at neon. Look at that one right there. He's a 0. And helium's a 0. Neon and helium are right here in this column. That column has a 0 charge. They're called the noble gases. And as a matter of fact, the really cool thing about the noble gases is they don't need anybody's extra electrons. They'll never give away electrons. They won't take in electrons. They're completely full by themselves. And so they don't have to throw away or take in. So they're 0. They're already neutral. They're full by themselves. As a matter of fact, everybody wants to be like them. That's why they're throwing away electrons and taking in electrons. They want to be full. So basically, these guys over here that are +1 that throw away 1, well, if this guy's number 11 and he throws away 1, he's now back at 10. Now, that doesn't mean an Na turns into Ne, but he has 10 electrons just like him, and he's just like him. So everybody wants to be full like the noble gases. See what else we have. Chlorine. and fluorine. Both -1. Fluorine and chlorine. This must be -1. -1. Yeah. Now, real quick, I'm going to go ahead and put the staircase. You probably need to do the same thing on yours. This staircase, as I told you in the other session, is super important. You're going to see why here in a second. So we have one column. Who else do we have? There's oxygen and there's sulfur right there. Oxygen and sulfur are -2. Oxygen and sulfur, -2 column. Now, why this is so -1 goes all the way down, -2 goes all the way to the staircase. Now, if you ever get a periodic table and you don't see the staircase, if you just lay your pencil or pen across there like that, you can see the staircase. It's real easy to see. It's just a diagonal. And so -2 goes down to the staircase, not under it. If you get under it, then you're in these transition metals that mess up their electrons. So we're really not going to mess around with them at all. So we just go down to the staircase. That's it. You'll notice that nitrogen and phosphorus are -3. Nitrogen and phosphorus are -3. All the way down the staircase. Or the carbon and the sulfur. Now I know there's somebody that's probably saying, okay, these had 1 in the outside ring. Throw them away to be full. These have 2 in the outside ring. Throw them away to be full. Skip the short ones. 3 in the outside. Throw them away. That means that carbon has 4 in the outside ring. Well, if you have 4 in the outside ring, that means you have 4 empty spaces. Now the challenge was, is it easier to gain 4 or throw away 4? The answer is, neither one of them look easy. So carbon and silicone, these two guys right here, don't do either. I'm just going to skip it. It's that simple. So +1 column, +2 column, all the way down. Skip the short ones, +3. So +3 is just these two guys right here. +1, +2, +3, 0, -1, -2, -3. Notice the numbers work like this. 1, 2, 3. -2, 3. They work together. You don't have to draw them like this all out. The periodic table itself shows you the pattern. That's why the periodic table is so awesome for using on the tax test. Because all you have to do is look and you know charges. For example, if I ask you, what is the charge of a cesium ion? You don't have to draw it. Since it's in column number 1, he's +1. How about an iodine? Another big atom. He's -1 because he's in the -1 column. So all you have to do is look at the chart and what column they're in. You automatically know what's happening. Now, I want to take one more second to show you something. Get these out, and I'm going to give you 2 things you need to make sure you write and put a star. I'll go ahead and put my star. Negative equals gain electrons. Positive means to lose electrons, and this gets more students because when they see something that says Na+1, they think, oh, plus means to get. You got an electron. That's wrong. It's the opposite of what you think. If it is a negative charge, you are gaining electrons. If you're positive, you're losing. Let me explain it to you like this, and then we'll be done. Let me grab a paper clip here, and let's say that this paper clip is an electron. And I have an electron, and I'm going to give it to you. Are you now positive or negative? Well, if I gave it to you, that electron's negative, so you're now negative. If I gave you 2 paper clips, like this, if I gave you 2 paper clips, you are now -2, because you have 2 negatives. If I gave you 3, you're -3. Now what happens to me? Well, if I have these electrons back over here with me, and I give you 1, I become +1. You became -1. If I give you 2, you become -2, but I become +2. This is very important to look at. Negative is gaining, positive is losing. This is how you can look at the trends in the periodic table and know exactly what somebody's charge will be.